Wall framing is probably one of my most favorite parts of a home project or work project or anything that I'm building. I can do the framing myself for the most part, unless I need help lifting a wall up. And once I got the materials, it's not too difficult. It's just kind of it's fun part of the project. And then once you get the walls up, you get to start to see how rooms lay out, and it's just kind of an exciting step towards finishing your home project. And so I hope that you're enjoying it. I hope you do enjoy it as you work through it. But I want to make sure to go through just some of the few components of framing so that you just have them in your back pocket when you're ordering materials. And so you kind of know what an inspector might look at or look for as you work through your framing. And so first, let's talk about just kind of some of the general components. Then I'll dive into a little bit of code reference for you and then show you a few pictures. But right out the gate, straightforward, right? You're going to have a bottom plate, you're going to have your studs, it's some sort of spacing, and then you're going to have top plates. I recommend, there is a code exception to use a single top plate on a bearing wall. So we're talking about bearing walls right here. But I would recommend just plan for double top plates. So you have a treated bottom plate if you're touching concrete. Anything that touches concrete is going to need treated lumber. So usually that's your bottom plate if you're sitting on a foundation wall. If you're in a basement and you're sitting on a slab, it's going to be a treated bottom plate. If your walls are up tight against your foundation wall, you're going to need treated lumber there. So you might save yourself the funds and just pull your wall out half an inch or whatever your requirement is. Pull that out. A lot of times insulation will get involved with framing a little bit, because wherever you're at, you're going to have a cavity that meets the requirement for the insulation wherever you live. Where I'm at, it's R21. We have to put in 2x6 walls on the exterior to meet the R21 requirement, unless we use some other type of insulation. Now there is insulations out there like spray foams and rigid foam board that might get you to an R21 and a 2x4 wall. But in general, most people where I'm at use 2x6 with bad insulation. Wherever you're at, if you're only required to do R13 or R15 in your walls, well, 2x4 is probably going to get you what you need. The question then just comes down to how much weight are you putting on it. So back to the basics, right? We've got a bottom plate. It's treated if it's touching concrete. We've got our studs spaced 16 or 24 inches on center. And then we've got top plates. There is a reference where you can use a single top plate, but if you're in a bearing situation, you're holding the floor, you're holding the roof, I recommend just stick with double top plates. It's easier, it's simpler, it pulls everything together, because that second top plate can overspan joints, and it can also tie your corners together, which is actually what they require in the code book, is that you tie all your walls together. And so if you use a single top plate in a bearing situation, well then your bottom and your top plate, your joints have to overlap, right? So you can't have two walls and you want those joints to overlap. Well, if you're using a double top plate, you just frame your walls up and then set everything, brace it off, and then go back after the fact, after they're all set up, and just go nail that second top plate up there. You cross over, make sure you get your connection at your corners. And if you have a long section of wall, so you got two walls buttoned together, well, you can just make sure that second top plate overlaps them both, ties them both together. They want to have 24 inches of overlap of joints. Okay, so when you have those situations, just make sure it overlaps 24 inches with the second top plate, and you're good to go. So there we've kind of just, that's kind of the basics, right? It's bottom plate, you got your studs, you got your top plates. Now you start to dive into a little bit of, well, what spacing do I need, right? Am I required to do 2x6? What am I holding up, right? You get into the structural component of it. Well, depending on where you live, you might already know, right? You might be like, I've seen a bunch of framing in my area. I've seen a bunch of new houses being built in my area. I maybe go walk one of them. If there's a new development in your area, stop by there and just look and see what they're doing. What are they using for framing? Are these 2x4s, 2x6s, and what is it holding up, right? For example, 2x4 framing can't hold up more than a floor and a roof. okay? And we'll look at the chart here, but like if you go jump into 2x6s, well, 2x6s can hold a floor and a roof, but be 24 inches on center, where a 2x4 is 16, okay? So then you're diving into, well, am I better off just put in 2x6s and go 24 inches on center, or do I stick with the 2x4s and go 16 inches on center? Well, that comes down to preference, you know. Before I dive into the chart, though, on the bearing side of it, I do want to just dive into non-bearing a little bit. So for those of you who are just finishing your basement and all the structural components are done, the floor's in, it's been there for years, I'm just finishing my basement. I want to make sure I'm covered, okay? Well, same concept. You don't need the double top plate. It can just be a single. And make sure you got treated material wherever you're touching concrete. And make sure you got room for your insulation. And that's about it. It's holding up drywall. It's going to have some wires run through for some electrical. It's got to hold up some insulation maybe if it's around a foundation wall. And maybe some plumbing or HVAC or whatever it is you have. But if you can hold up drywall, you're not messing with the structural side of it. So the biggest thing as an inspector that I find, especially on basements, is not the treated bottom plate. Homeowners forget to put it in, and then we got to figure out how do we cut out that bottom plate? They've already ram set it into the concrete. How do we protect it? What do we do? And so I would just tell you right off the get-go, make sure to get your treated materials. So many homeowners forget that component of it, and it's just a pain in the butt later. Even if you forget to like pull your studs out from the wall far enough for your insulation, that's not the end of the world. People will go back and they'll just nail like some 1x material on there, some 1x1s, and they'll just fur it out. That's not the end of the world. But that treated bottom plate, that's just a pain. So don't forget that on your project. But again, non-bearing walls, 2x4s, pretty standard, 24 inches on center, pretty standard. You can go 16 if you want. A lot of guys, at least where we're at, they just stick with 2x4s, 24 inches on center with a single top plate and your bottom plate, and that's it. It's not holding anything up. As far as like a tip for framing, if you've got a basement floor that's like it's sloping one way or another, and you just can't figure out where to cut your studs at, and you don't want it to be a pain, well, remember that it's non-bearing. I framed our basement and I fought with walls back and forth, and by the time I got to the end, it dawned on me that, well, they're non-bearing. I don't need to go through all this effort to make sure every stud's perfectly, tight and solid. Find what your lowest point is, frame your wall, set it up, and then shim between your floor joists and the top plate. You want it to be solid. You don't want any squeaking or anything like that. You could throw some glue in there, some liquid nails or something like that in the shims so that the shims are nice and tight and solid, and you should be fine, unless you've got like huge gaps between your bottom of your floor joist and your top plate, where you could end up with some movement and cracking of your drywall. You should be fine. I mean, if you're just talking about half inch, quarter inch, shim it, make sure it's tight so it doesn't move. Make sure your nails are long enough to connect and pull everything together, and you should be fine. So let's look at so that's kind of non-bearing. So let's dive into back over to the bearing side of it. And I'm going to show you a little bit of code, just so you're kind of in reference to what may be required if you don't know. So here we've got 2x4s and 2x6s. They talk about 3x4s and 2x5s, but I think most everywhere people use 2x4 and 2x6. And you can see here, all it's holding up is just a roof right here, okay? And they're telling you can do 24-inch on center studs with 2x4s or 2x6s if you're only holding up a roof. So it'd be a slab on grade. That would be a crawl space, anything that's just holding a roof, right? They do talk about, here we have this note C right here. And so they're talking about habitable attic assemblies supported by 2x4 studs. And they're just telling you they want the roof span max of 32 feet. So if your house is over 32 feet wide, you might end up having to hop into 16 inches on center or hop over to 2x6s. Okay, it says where the roof span exceeds 32 feet, the wall stud shall be increased to 2x6, or stud shall be designed in accordance with an engineer. Which, as a homeowner, do-it-yourselfer, you're not going to want to get engineers involved. It just costs you a bunch of money. You're better off to just kind of follow the prescriptive code method. And so in that case, I would probably just hop over to 2x6s and be done with it and move on. But you can see how, again, we hop over here and we move to where we're holding a floor system and a roof. Okay, so this would be like maybe a basement. It's got a floor on it, or even it's anything that's just holding a floor and a roof. Okay, so those particular walls, here would be the requirements. You can see you can still get away with a 2x6 at 24 inches on center. Okay, and we don't see a lot of houses in my area that have this many stories, right? Where maybe it's a basement and then you've got 2 stories above that. We normally just don't see those anymore. They may be in the area where you're at, but at least where we're at, we don't see them. And so we really are just kind of focused on these 2 columns right here. And you can see how 24 inches on center for 2x6 is standard and allowable. It's just these 2x4 walls, depending on where you're at and what you're holding up, you can be required to hop down to 16 inches on center. So again, I just don't see a lot of houses that are this tall, but if you do, just know that you're not going to be able to use 2x4s. You know, if they're holding up 2 floor systems and a roof, you're going to have to go to 2x6. Maybe a townhouse or something. I've built some townhouses back in the day, and they were multi-story townhouses, maybe where there was like 0 lot lines. And 0 lot lines means that the houses, townhouses are right next to each other. And so there's not a lot of space to go out wide. You have to go up. And if that's the case, well, if that's something that you're doing for your project, just know that you're probably going to end up with 2x6s at 16 inches on center. I just don't see a lot of that. And so if you go back to kind of just the general components, keeping it simple, I got my treated bottom plate. I'm going to do 2x4s or 2x6s, 24 inches on center, 16 inches on center, and I'm going to do double top plate. It's like, okay, cool. And then, so now what about the actual putting it all together? What are a few things to think about? Well, what you might think about is attachment methods, right? So do you have a nail gun, a pneumatic nail gun, so it runs off an air compressor, or are you hand nailing everything, right? A lot of people will go in and they will crown all their studs. So what does crowning your stud mean? Well, all studs, when they come out of the kiln, when they're cut through the tree, when they come out and they're dried, they usually will have like a crown in them, right? They will kind of arc one way or the other. Sometimes they're pretty flat, but a lot of times they have just a little bit of a crown in them. So if you were to pretend that like this 2x4 was, say 10 foot or 8 foot stud, if you were to look down it, right? If I'm looking down this, it would have a hump in it on one side or the other. Well, you want to make sure that those are all flipped the same way. If they're interchangeable, then when you're putting your drywall up, when you put your level up, your wall might be level, but each of those studs is crowned. Well, if they go back and forth on you, you can have problems with your drywall. So just kind of a little tip, make sure all your studs are crowned the same way. When I frame, I always crown everything up so that no matter what happens, when I lift my walls, they're all framed. I'm not necessarily worried about whether or not the crowning is on the outside or the inside. I just want to make sure they're all the same way, in the same direction. If it's a flat stud, it's a flat stud, but just make sure you crown them all the same way. When it comes to framing, layout, right? So what I would do is I just take my top plate and my bottom plate. So here's like a little chunk of treated material. Just say that these are like, again, maybe you're running like a 14-foot wall. So you got 14-foot bottom plate, 14-foot top plate, smash them together like this. Make sure the ends right here all line up. And then you just pull your tape and you just start marking your spots. But you can mark them both with your speed square, right? So every 24 inches, every 16 inches on center, you mark those locations so that when you then pull them apart and you set your studs between them, you crown them the right way, get your nail gun out, and then you can just 2 nails right here through into your stud, hop over to the other side, 2 nails into the stud, and boom, there you go. You've got your wall. It's all nailed together. It's crowned the right way. You lift it up. You put up some temporary bracing. You walk along the wall with your level, and you make sure everything's level. Put your bracing up and nail it off. It's all braced. You frame your next wall, lift it up. Maybe you do a corner wall, you frame it, you lift it up, you brace it, and you kind of work your way around the house. A lot of framers will frame everything up, and they'll have bracing and kickers all over the place, and then they'll go back and they'll run their level again and make sure nothing moved, and then they'll run their second top plate. They'll tie it all together, pull it together. So if you have like intersecting walls, right, an interior wall that's buttoned up to an exterior wall, where you're going to want that double top plate, that second top plate, to carry over into the exterior wall, right? Pulling it all together. So those are components that you're going to want to think about if you have a big project, right? Or a bigger project, an addition that's got multiple rooms in it. Just make sure that second top plate pulls everything together. I'm going to show you a few more code references. I don't want this video to get too long, so I want to make sure to cover the basics up front so that you can hop right into it. And if you need a little more information, you can come back to this video. But let me dive into a little bit more code reference, and then I'll show you a few pictures. So here we kind of talked about the top plates, okay? So here they're telling you wood stud walls shall be capped with a double top plate installed to provide overlapping at corners and intersections with bearing partitions, okay? So again, they're talking about these bearing partitions. End joints in top plates shall offset not less than 24 inches. So that's where I said that, if you have intersecting walls, make sure that the top plates at the joints overlap 24 inches minimum. A lot of framers get a lot more than that. They just kind of lay things out that way. They're telling you that your plates shall not be less than 2 inches nominal thickness. So 2x4, 2x6. And be the same width as the studs, which that's pretty straightforward. Here's kind of the one little part where it talks about a single top plate as an alternative to a double top plate. Again, I would tell you just stick with the double top plate and make things easy. But maybe it's a budgetary thing and you just want to roll with it. Here is what you can work through in reference. The big thing is it says the rafters or joists shall be centered over the studs with a tolerance not less than 1 inch. So essentially, if you do decide to do a bearing wall with a single top plate, all your bearing points, so your joists and or your rafters, have to bear right on top of the stud, essentially making the top plate not necessary in a sense, right? I mean, it's necessary to keep the wall together, but the bearing points just follow all the way down to the foundation. I mean, at the end of the day, that's the number one component to framing, is making sure all the weight transfers down to the foundation wall, to the footing, and then transfers into the earth, right? That holds it all up. So that is one thing you could do if you were compelled to do it. Maybe it's a little garage or something that you're doing. It's not heated, and it's just holding up a roof. That's all it is. Maybe it's like a one-car garage. You're rebuilding it. You used to have one. Well, you might be able to work down this component, save yourself a little bit of money. But also, if it's something that small, a couple more 2x4s might not be the end of the world. But you could, if you're doing a stick frame rafters or trusses, you could make sure they line up and set right on your studs. And you should be fine with 2x4s on a single top plate. So bearing studs, it says where joists, trusses, or rafters are spaced more than 16 inches on center, and the bearing studs below are 24 inches on center, such members shall bear within 5 inches of the studs beneath. Okay, so they're just telling you, and I don't want to confuse you on this because it really kicks in when you're using 2x4s. That's really what they're getting at, because the exception down here is it says the top plates are 2 by 6 inch or 3x4 members. Well, we use double top plates where we're at, and we have to use 2x6s. So where I'm at, it's not kind of a non-issue, right? I'm not too worried about any of this component because I have double 2x6s as far as the exception is concerned. But where you do have these joists, trusses, rafters are more than 16 inches on center, which rafters, you know, or trusses, standard engineered trusses are usually 24 inches on center. So that would put you over 16 on center, and the bearing studs below are 24 inches on center. So maybe it's a 2x4 wall. It's only holding a roof. The roof is spaced at 24 inches on center, and you have your studs at 24 inches on center because that's what the chart showed. You could do 2x4s at 24 inches on center if they're only holding a roof. It's just saying that such members shall bear within 5 inches of the studs beneath. Okay, so just keep that in mind. That'd be maybe one component where an inspector might show up and you'd be like, man, I did not know that. So if you're using 2x4s, just make sure that your that anything you have that's spaced more than, so maybe your floor system even is 19.2. Maybe you're framing your floors at 19.2 and not 16. Same situation. Make sure that your members shall bear within 5 inches of the studs beneath. It's just trying to make sure that the weight transfers all the way down and you don't get any sagging of your top plates. Okay, so here would be like what they call a cripple wall. So they have a step in their foundation. We call it a pony wall as well. So if you hear the word pony wall, cripple wall, it's just framing up this little wall so that everything's nice and flat. And then you can build your floor, and then you build your walls on top. So here you've got your bottom plate. Here you got your double top plate. They're telling you right here, staggered joints 24 inches or use splice plates, right? Talking about that. We'll dive into headers on the next video, and we'll kind of talk about making sure your headers are laid out properly. We talked about, hopefully when you guys did your foundation, you got all your anchor bolts in the right place, and so you're all set up for anchor bolts. But in a nutshell, that's about it when it comes to framing a wall. It's a lot of fun and it's pretty simple. So here would be like an interior wall that's non-bearing, right? You can see this floor is running the other way. They still use double top plates, but you don't necessarily have to. You can see where they pulled it off of the foundation wall. So they have room for all their insulation. Here they're asking for 2x4s, furred, 16 inches on center with R21 insulation and 1/2 inch drywall. So they pulled it off 2 inches. Bearing wall right here. So they're allowing room for R21 in the walls. They've got double top plates. They've got their metal connections from their truss or their rafter down to their top plate. And, you know, pretty straightforward. Frame those walls up. Make sure that they're nice and level. Crown them all the same way. Make sure you got room for your insulation. You should be good to go. So that should cover the basis for framing walls. I will hop over here real fast and just show you a few pictures so that maybe you're more visual and you want to just see kind of a couple pictures. Let's look at those. Okay, so let's see here. So this would be like a bottom plate, right? And it's treated and you don't see any nails or anything. Now you can toenail, right? Toenail is where you just kind of shoot it in at an angle, but they've, like I kind of showed you, they laid everything out on the ground. It's all flat. They've nailed in through the bottom and then they lifted it into place. And so you don't see that. Now I don't see any anchor bolts in here either. And so it might have been a code correction call that maybe I made when I was out there. But you're supposed to have anchor bolts within 12 inches of the plate breaks. So here's a break in that plate. And so there would have needed to be an anchor bolt over here and an anchor bolt in here or right in here. And maybe they are there. I just don't see them in this picture. It would be like new framing. And so you can see right here, they've got trusses right here. And you can see these ones looks like they're 16 inches on center, just based on how the layout is with the trusses above. No big deal. 2x6 is at 16 inches on center. It's only holding the roof, but hey, that is a strong wall, right? It's got all that extra material in it. I think that they used, instead of using an actual hurricane clip, they used a screw, a truss screw. They now manufacture a actual screw that's like a really long screw that goes up through these top plates and into the bottom of the stud or into the bottom of the truss. And so you don't have to put hurricane clips on anymore. That's an option. If you see this video and you're like, man, I hate installing hurricane clips and all the millions of little nails that I have to put in, go look for those truss screws. might help you out and be a little bit easier to put in. This particular house, so you can see right here, this is interesting, and it's kind of off topic a little bit, but you can see your building wrap right here, and then there's no building wrap right here. Well, this particular house, they did what they call T111 over the top of this, and then the front of the house, they did more of a lap siding, just kind of break up the look. And so for T111, that the sheeting actually meets the requirement for the sheeting and for the exterior siding material. And so they put the building wrap right over the studs, put the T111 on, and then over here, though, they need to have that sheeting because the lap siding they're putting on does not meet that requirement for the sheeting, right? The 3/8 inch minimum sheeting. So what they do is they put up 7/16 OSB, and then they go and lap side it. So that's an interesting concept back and forth, depending on what type of materials you're using. Your building wrap might be right on the studs, or the building wrap might wrap over your sheeting. So here's a situation where you can see they went and blocked, right? So this is probably a 9-foot ceiling, and so they needed to block between here to make sure they had nailing. Here it looks like they went a little overboard. Usually you're going to do that when you get into shear components of your framing. And I'm getting off into the weeds a little bit here, but I want to make sure that you kind of see how they went and blocked because they wanted to make sure they had room to nail off their edges. Here's your hurricane clips. And again, looks like it's 16 inches on center, the way that they did it. What about an existing house? So here's an existing house. It's all 2x4. Here's the old sheeting that was put on there. They tore it out. They're going to redo it. They haven't messed with anything per se. These are all existing windows, existing framing. Maybe they went and just added a stud to make it better than it was, but it's existing. So at least in the jurisdiction I'm at, where I work, we don't make people go tear things out unless it's a complete safety hazard. This house has been sitting here for however many years, and it's been perfectly fine. And so if we get people to make it better than it was, that is awesome, right? And so we encourage people to do that, but we are not going to come in here and say we need to tear all this out and put 2x6s in, right? And we're not going to tell them that they have to install brand new headers over everything. It's been sitting there as long as it has. Now, if they were to go in here and make this bigger, say that maybe they want a bigger window right here, well, now they got to put a header in. Now they have to bring it to code to the best of their ability structurally. They don't necessarily have to fur it out for larger insulation because it was existing. But in this particular instance, they might have to add another header in here if they made it bigger. That would be kind of what we would require where we're at. Here's an old existing house. So you got the old rafters, and there's actually a bonus room up above here. And so they went in here, and you can see this is a bearing wall because you've got interior. And interior bearing walls have to meet the same components as exterior bearing walls. They just don't have to necessarily meet any insulation requirements. So they don't have to be 2x6s if 2x4s will work, depending on what they're holding up. But they've gone in here and they've just cleaned it up, right? They have all these existing studs. They added some headers up here above these openings. You can see that over here they added some beams. They added a beam up in here and a cross beam to kind of pick up a bunch of this weight. They want to sturdy everything up. They sistered next to all of these studs. They want to make sure they had solid bearing under here. They did a great job. They cleaned it all up and they made it better than it was. And I feel like as an inspector, I use that word all the time, or that sentence. You make it better than it was. It's an existing situation. I can't come in here and make you tear a bunch of things out. You made it better than it was. That's awesome. That means it's going to be great for whoever owns it down the road, or for yourself or your family. You're going to know that it's safe. Here would be like a basement and single top plate. It's not holding anything up. It's literally just there for insulation, drywall, and maybe some electrical. From what I can tell, I think I may actually made a code call on this because here they did not use a treated bottom plate. So I have to figure out how to go in there and swap that out. One of our fixes where we're at is sometimes we'll allow people to put like felt underneath there. If they can get a crowbar under there, they can run some felt underneath of it and try to separate that bottom plate from the concrete and give it some protection against moisture. And sometimes it works, sometimes it doesn't, and I wouldn't tell you to go down that route on purpose. I don't know if where you're at, if your inspector would allow it. I just know that where we're at, sometimes we'll allow that felt to be placed underneath there and just provide that separation. Here's another one. You can see they're just kind of framing it in. They left sections of it, of the framing out, because they're going to cut in a window here. Maybe they're going to cut in an egress window. I don't know what they have going on with all these marks, but same kind of concept, right? Just 24 inches on center. Just, frame your walls up, slapped them up, and nailed them into the joists, and made sure they were level, and they were kind of done. Let's see here. Here's another existing situation. They went in there and added a header over it. They got to make sure they put their studs back up above so that the header's actually holding up what it was intended to do, which was transfer all the load in between the door, across, and down. So here they would have had to add a couple studs in there, cripples, whatever you want to call them, and over this new header, transferred it down, and it was good to go. So I think that should get you through wall framing. Hopefully I didn't confuse you. I want to keep it really simple, because at the end of the day, it really is one of the most favorite parts of a project for me, at least. And so I hope that it is for you as well. Crown your studs, treated bottom plates, double top plates I would highly recommend. And just make sure you size it properly. If it's bearing, if it's holding something up, just make sure that you can use 2x4s if you're going down that road. If you're using 2x6s, you're probably just perfectly fine. Not an issue whatsoever. Interior walls, usually you can get away with 2x4s no matter what, depending on what they're holding up, if they're bearing or non-bearing. And if they are bearing, just make sure maybe you got to go 16 inches on center instead of 24 in those particular areas. On a side note, if you got a big plumbing wall and you got a whole bunch of plumbing going in, put in a 2x6 wall, because 2x4 wall with a bunch of plumbing, you're going to hack it all up and it's going to just look like a big old mess. So that's just a little tip there. I've seen it too many times where people have gone in, and even on like bearing walls, 2x4 bearing walls, they've tried to run a 2-inch line through that wall and there's nothing left of it. And so then we have to figure out a way to get our bearing back into that wall, and it can be kind of a pain. So I hope that helps. I hope you're having fun with it, and I'm going to hop into the next video and go over headers. So after you've gone through this, make sure you get the structural component of headers in, which headers, beams, girders, that is transferring load over openings. And I'm going to dive into that here in some of the charts a little bit in the next video.